Exercise 11.8. I'm going to go through examples from there. Is it starting? Is the blue light on? Okay. All right, give me a second. Just a few notes. So we've learned how to differentiate sine inverse, which is that we're basically just going backwards, integrating it. These formulas are not in the formula sheet. In the HSC formula sheet, it comes in a different form with f-x on top. Have a look at it yourself, but it's not, I don't find it user-friendly. So it's best to actually memorize these forms. Give me a minute. So let's get started. So if you differentiate sine inverse, you get that. So that means if you integrate this, you obviously just get back to that with plus c. Yep. Same thing here. Remember, if it's a minus, it's cos inverse. Oh, it's just x, sorry, nothing in the bracket yet. Whoops, just cos inverse plus c. This one is tan inverse x plus c. Now, in general, though, if you have some number in front of x or x over a, so it'll be that. So instead of the 1, just keep that number a in mind. Same thing here. So we're just going to learn how to apply these. These are very straightforward examples. So 25a, so the first thing you got to note, that's your a squared. So that means your a is obviously 2. There's no minus, so that's just sine inverse. So that's just sine inverse x over a, in this case is x over 2, plus c. Pretty straightforward, yep. This one's got a 2 on top. I usually like to take it out in front and put a 1. And then focus on the number. It's not x squared. A squared is obviously 3. Then a is root 3. And then it's just going to be sine inverse again, but with a 2. So we got then equals to 2 sine inverse x over a. In this case is x over root 3 plus c. Now this one, once again there's a 2, so let's just take it out. Now with this one though, you always want the number in front of x squared to be 1. You don't want a number in front of it. So factorize it out. So I'm going to have 1 over 20. I'm going to divide everything by 25. If I do that, okay, if I divide everything by 25, I need to counter that or do the opposite to make it still the same thing. So does this make sense? So I'm trying to get rid of 25 in front. So I divided both of the terms by 25, which is what I go in the bracket here. But obviously, to make it I can't speak. Yeah, to make it in the same expression as above, you've got to times it by 25 to make it worth the same thing. Now, square root of 25 though, if you take it out, what is it? Square root of 25 is 5, right? So what you want to write is actually now 2 over 5 integration of that. The bracket still stays the same. So you always want to write it in this form. And then from here, remember that's your a. A squared is 4 over 25. So your a is square root of that, 2 over 5. With the 2 over 5 multiplied in front, this is sine inverse once again. Sine inverse. X over that is just that reciprocated. I don't like that noise. Yeah, does that make sense? Just make sure to do this. Don't make silly errors when it comes to doing that. That doesn't help during my recording. Anyway, those are the easy questions. Now, open up to your exercise 11.8. I'm going to go through the questions I wrote up on the board. All right. I'm just trying to wait for that noise to stop, but I don't think it's going to stop. Oh, just FYI, I didn't think I have to go through this. Your very first question in your exercise is this, but I don't think I have to show it to you. I'm going to let you guys try it. So what if you had something like this, and they actually tell you Okay, so if they give you a question like that, just make sure then just use substitution method. I don't want to go through that, but you guys get the idea. Okay, you're going to have something in the form of like one of the, like in that form. Just use the sine inverse formula after you let u equal to that, because you're going to have 16 minus u squared. Yeah, you guys should be fine with that. The one time, hi Kelly, the one time I record, it's like, oh, now it's finished. I bet it's going to go again. I'll give you some time to jot it down, do whatever you need to. Kelly, just a quick brief, just because I'm going to rub it off. So, how do I like do TLDR version of this? So you know how we learned to differentiate sine inverse, which is that? If you integrate that, you get back into sine inverse, okay? So we just learned to use the formula early. So if it doesn't have a minus, it's always sine inverse. If it has a minus, it's cos inverse. If it doesn't have a root, it's tan inverse. Just always focus the number inside the square root. So that's your a squared, so your a is 2. And you're just replacing that a with the 2, and then just get your answer. Look, with these ones, it should be pretty straightforward. The only one that's not straightforward is example 26a. Just make sure the number in front of x squared doesn't have a number. That has a number. So divide both of these terms by 25 to get rid of the 25. If you do that, you get that. But because you just divided these two terms by 25, you've got to multiply the whole thing by 25. So write 25 bracket outside. And then square root of 25 comes out as 5 outside. And then you can see that there's no number in front of x squared. Well, it's 1. That's your a number. And then just plug in the formula. Okay. Did you learn this before in tutoring? Oh, you have? Kind of? Okay. All right. Look, I really need to rub the board. So if you can't write there, can you just quickly take a photo of it maybe? Or these notes are already up there in my lesson from last year, so. Can I move on? All right, I'm going to rub the board. All right. Alice, Shirley, you're going to appreciate the next few questions. All right, let me just set up the board. Question 2. What did I write? No. What did I want you guys to try? Oh, this one I want you guys to try. It's not something I want you to go through. I'm going to go through 3T and then you guys try 3S. 3S. Okay. 3S. Wait. What did I do? No, I want to go through 3T. You guys try 3S. Oh, what am I doing? Oh, I can't even read my writing. There we go. 1, 0, 10 inverse. That's my question. And then after that, I'll be going through 16b. 14b. 14a. Just give me a minute. Sine inverse x plus x over 1 minus x squared. And then hence show that or hence find that basically. Okay, now this question in 4 unit there is a technique that you can use to actually integrate that, but in 3 unit there isn't. So how do you do it if you don't have the rule to integrate tan inverse? You're going to do it graphically. Alright, so which comes to the next point. It is quite important you guys remember how tan inverse x looks like graphically. Here's how it looks like if you forgot. Sorry, that's not that noise, I can't help it. Anyway, that's your tan inverse x. You don't need to know the, I mean for this question you don't, but do you guys remember what the asymptote was? Is it pi over 2? I actually forgot, so I'm asking you. Okay, I'm going to believe you, it's pi over 2. All right, now they want you to find the area from 0, let's say 1's here, so they want you to find the area of this. But obviously can't integrate that because we don't have a rule for that. So here's how you do it. Find the area. What we're going to do is we're going to find the area of that section, and then I'm going to take it away from the area of this rectangle. Yeah, can you see that? So how do I find the area of the blue part? Well, right now what we have is y equals to tan inverse x. What I'm going to do is make x the subject. If I make x the subject, you tan both sides. That becomes tan e. Sorry, lame joke. I just thought it sounded funny. Tan y. And then what you do is you integrate tan y with respect to y, but because I'm finding the area with respect to the y axis, how do I find that point there? So basically, when x is equal to 1, that's basically your y value there, isn't it? And what angle gives you, does that make sense? Yeah, tan 45 degrees is equal to 1, or tan, just technical term, tan pi over 4. Yep, so that's why I'm going to integrate from 0 to pi over 4. Okay, that will give me the blue area. And if you go through, actually, this is a good question. How do you integrate tan? There's no rule for it, but you need to break it down. What's the definition of tan? Sine over cos, right? So that's what you need to do. Sometimes, like even for myself, I forget how to integrate that. And how do you integrate that? It's ln. Because remember, so when it comes to this, the original comes on top, but the differentiation of the bottom goes at the bottom. So differentiation of cos is minus sine. Yeah, and you'll find that the answer is negative ln cos y. Yep, remember we briefly went through that rule in 2 unit. And then basically, if you substitute pi over 4 and 0, I didn't do it. Okay, I'm going to let you guys try it out. I think I could stop here. So basically, what you need to do to get the area of that, what's the area of the rectangle? That's the length, 1 times pi over 4. Yeah, so 1 times pi over 4, obviously is just pi over 4 units squared, and then take away whatever answer you get here. All right, and then that will give you the answer you want. So that's how you do this question, 3-unit method, if there's no formula to do it. So given that I did try 3S when it comes to doing the exercise in your spare time. All right, now next question. Are we ready? Am I going too fast? 14? 14, I'm not going to go through. It's something you should be able to do. They want you to show if you differentiate that, you get that. That's just product rule. I'm just going to give you a start, but I'll leave it at that. Okay, use product rule, you'll get that. That's not hard. The question that I want to go through was the next part. It's question B. So they want you to basically use this result to find that. So basically, integrate sine inverse x. But they want you to use the previous part, not graphically like I did there. I mean, I'm sure you can try it graphically, but if they want you to use the previous part, you have to. So how do we integrate sine inverse x given that? Well, the technique is, and I've shown you this before, if you got d over dx, and if you want to get rid of that, what do? You integrate it, remember? So if I integrate this, that gets rid of the d over dx, and that means I have to integrate both sides. Now, this is technically, if I'm integrating everything, like this is technically that and that. Yep. Now, what does that leave? So that leaves just the other side by itself without the differential sign. That leaves, hey, this is actually what I want, because that's a question. So let's make that the subject after I write this down. dx plus that as well. All right. So the question is, oh, finally. Sorry, I got too excited. I was going to say the lawnmower is done. I'm teaching in peace. And then I threw my pen down. All right, and then from here, make that the subject because that's what I want. So then integration of sine inverse x dx is equal to this. Okay, take away that because I'm bringing it to the other side. And that's basically how you do it. You got to continue it. You got to figure out what this is. How do I figure out what that, what's the technique that we just recently learned to integrate stuff like that? Yeah? Using substitution method. Let u equal to, what do you want to let u equal to in this case? The thing inside. Okay? Because if you differentiate that, you're going to get minus 2x. That's going to cross off the x out. Yeah, I'll let you girls try that out, and then that should answer basically your question to this. Just make sure to substitute that and that integrals at the end, and yeah, that's basically the answer. All right, good question. It's not my main course yet. Anyway, take a photo of this, and then I'm going to move on to this question. That's a hard one. That got me last night. Oh no, sorry, not 14b, question 6. So question 6? Yes, question 6. What a beast. Can I rub the board or are you guys still copying? Yeah, still copying? Okay. Oh, how long's the video so far? Oh, that's not too bad. I was probably going to reach up to 30 minutes. Is the board even clear from the iPad? Yeah, you can see that, except for the light. Oh, I should put the blinds down. What do I have first period? Oh, you know what? Can I just rub this side of the board then? That's all right, yeah, just the formulas. And then I might get started soon. All right, question 6. You're still writing? Okay, all right. Question 6. So we need to draw this. Hello. You got a message. Should I do it in blue or red? I'll do it in blue. Can I go through it? Not yet? Yes? Silence means yes. That's what I learned from you girls. All right, girls, let's look at question 6. All right, so on the same axis, sketch the graph of y equals to 2 sine pi x over 4 for 0, between 0 and 2, and x equals to 2 sine pi y over 4. That's not hard to sketch. This one is a bit confusing, so I firstly want to show you that. So first of all, with this one, if I want to sketch this, okay, the amplitude is 2, so it's going to go through to the peaks at minus 2. Now for the period, remember the period formula is 2 pi over n, so in this case it's 2 pi over 4. Is that alright with you girls? Yeah. And then if you do that, you want to get 8. So that means one sine curve ends at 8. So I'm going to quickly do that. Alright. So that if that's 8, this is 4. All right, and that means this point must be 2. Okay, so I've done that. Now, on the same axis, they want me to sketch that. Is everything all right? Yeah. Now with this one, okay, you got to look at it. You got to look at it upside down. I guess that's if that's a word. So if the amplitude is 2, that means the peaks are at 2. So that is going to be a peak, and the other side of the peak is going to be minus 2 here, if that makes sense. All right? Now the period is still 8. It's still pi over 4. But how do you sketch it? That's actually quite tricky. That actually got me. So in order to actually know how to sketch it, does the curve start from the 2? Does it start like that? How do you know? Any guesses or any ideas on how to approach it? Here's what I did to get an accurate graph. So what you do, you substitute some values to see where it starts. When y equals to 0, let's see what x value we get. When y equals to 0, that's just x equals 0, because 2 sine 0 is literally 0. Yeah? So when y equals to 0, x equals 0, so it will go through that point. Let's get another point because that's not very clear. Another point that you can use to get what I did, what do we get when y equals to 2? So when y equals to 2, let's see what x value is. So that's 2 sine 2 pi over 4, 2 pi over 4, pi over 2. And 2 sine 90 degrees in the calculator is x equals to 2. So at y equals to 2, x equals to 2. So it's actually meant to be at the same point, at the same peak. All right. And then one more to show you when y equals to 4. So let's see what happens if I double it. Okay, x is equal to 2 sine 4 pi over 4. That's just pi. And that's going to give you 0. Wait, yes, 0. Okay, 2 sine 180. Can someone double check that? I'll do it. 2 sine 180. Yep, 0. Okay, so here's what it looks like. So it's going to go through this. Oh man, this is such a bad scale. Hold on. It's meant to look like this. Okay, and then on this side, it's meant to have -4. All right? Okay, so that's your graph. Now, that's actually not the hard part. They only want you to sketch it for between 0 and 2. Just rub it out later. It's okay, we'll just work with that in the time being. Find the area of the region enclosed by the curves. So the area that they want you to find is this. Yep. Okay, so that's the hard part. In order to do that, I need more space. Can I rub all of this now? The other side of the board? Think about it, because that's actually a very hard one. Or maybe there is an easier method that I don't know. Yeah, Shirley? This is definitely like a band 6 question. Or high band 5 at least. So we need to do some manipulation like we learned last time. Okay? Do we add or subtract? And if we add or subtract, what do we subtract it from? All right? So I'm going to just basically show you how to approach it, and then you guys can maybe tell me how, if there's another method you can think of. So let me first of all draw the two areas out separately, okay, just to give you an idea what we're dealing with. So first of all, we got this. That's your first graph. Okay, and I can find the area under this for the blue part. We got this, which also ends at. All right, so we've got two areas that we can find, the one under the black and the one with the blue from the y-axis. Now, one thing to note, put it in red. One thing you need to note, it's the same, okay? It is the same. It's just mirror reflection of the other. That's, okay, one thing that I want you girls to keep in mind. All right, so initially you might think, well, if I subtracted those two areas, will it work out? It won't. If you subtracted those areas, you would actually do the opposite. You're actually finding everything else but not that. So subtracting them won't work. So here's how you do it. First of all, if I add those two areas, what I'm going to get is this. How do I draw this? Hold on. Let me do it in red. No, I'll just do it in black. You're actually going to get the area of a rectangle because you're getting the area from here, and then you're getting the area from here. But what you'll realize, this is a very important thing to note, with the area in between, girls, when you add those two areas, this is the important part. Does that make sense? You're getting double, 2 layers. Because when you're adding these two, you're getting that portion twice. One from here, one from there. Okay? So if we're clear on that? Now, with that, if you subtract now this area with just the area of the, is it a square or rectangle? It's a square, right? Yeah. If you subtract it from just the area of a square, which is just 4 units squared, girls, if I subtract it, do I get what I want? Think about it. Do I get what I want? The answer is yes. Okay? Question is though, the next question I have to ask myself, when I subtract these two areas, am I getting double the area or just single layer? You got, it's just single. Can you see that? There is 2 of these, and in here there is already 1 of these. So if you subtract these 2, you're getting that area, just 1 layer of that. That's actually the hard part that took me a while to understand. So basically that's how you do it. So let's now get the expression. All right, so to get, obviously this is the bigger area, so that take away that, not that take away that. Let's get that clear. So the answer is, the expression is, let's use this. Integration of 2 sine pi x over 4, integrated from 0 to 2. Now, I don't need this expression. I don't need to find the area for the blue part because they're the same area. So all I need to do with this is just times by 2. Timesing by 2 gives me that area there. And then all I need to do is just subtract 4 to my answer, and that will give you your answer. Okay? That's how you do it. All right, that's it from me, girls. I'll turn that off now. Hey.